Okay, so this is chapter 4.3 about the data link layer protocols, because now we are moving upwards in the OSI model and we are now on layer 2, the data link layer, which takes care of media access. So when and how are we allowed to send data on the cable? So we need to have different rules taking care of that. And in real life, we have different protocols that will take care of it. And to be honest, we also divide the data link layer into different sub-layers again. We have the max sub-layer, which is the media access control sub-layer, which takes care of, combined with the physical layer, what type of media we are using, the type of access control that we have, when and how are we allowed to send the data. Then we have the LLC layer, the logic link control layer, which will take care of the upper layer protocols. So whether we are using IP on top of that, or we are using IPX or AppleTalk or whatever kind of protocol that we can use, the LLC layer will take care of communicating upwards, whereas the MAC layer will communicate downwards. And depending on what kind of an environment that we are in, we have different needs. For instance, on a data link protocol that have an environment where a lot of errors will happen and which are slow, well, then we probably need more control than if we have a fast connection where we don't really have that many errors. So for instance, on satellite communication, we will need to probably control more than just on a local area network. And also we need to have the rules set. When and how are we allowed to communicate with our network? So, for instance, on an Ethernet connection like we have here, well, then there are actually no control at all. When I have something to send, I'll just send it. Well, that's not entirely true, because what I do is that I listen to see are anyone else sending. And if no one else is sending, well, then I can just talk or send my data. Whereas on serial connections and in other types of topologies, we might have some other rules that I'll take turn. I'll wait for it's my turn to send something. And this is what is put into the data link protocols. I talked about earlier in this chapter about asynchronous communication. So somehow in our data link frames on this level, on this layer, the PDU is called a frame. I need to some kind tell the network that now I'm sending something, and we are having a specific bit pattern which denotes the start of the frame, and then I have another one which tells us this is the end of the frame. And then typically I have some kind of a header where I have the addresses, some kind of quality control, and then at the end I could have a trailer with a frame stop, but also with some kind of error detection if something goes wrong. It could be a checksum which can be calculated, and if the checksum has changed when I receive the packet, well, then I know that there has been some errors involved. So overall, when we are sending something, we are creating this packet or this frame on this layer, where I put on the header and I put on the trailer. I put on the address where I'm going to send it. This is typically the MAC address. And then the type field could be what kind of layer 3 protocol am I working with? Is this IP or is it ICMP or whatever is it? This is typically something that my LLC layer will take care of. And then it could be control bits, and then, as I said, error connection and a frame stop after that. There are different link layer standards, data link layer standards. We have typically what we are using is 802.2 and 802.3, which is the Ethernet standard. We have some older types of technologies as well, like the token bus and the token ring and the token passing. 802.11 for wireless LANs, 802.15 for Bluetooth, and so on. We will have a look at some of these data link standards in class. We will work with Ethernet a lot, but we will look at what token ring and token bus is in class. And that's it for this chapter, very fast.